So we want to look at virtual work method, and then it uses the law of conservation of energy to obtain deflection and slope. Now, if we take a deformable structure of any shape or size and we apply a series of external load P on it, it causes internal load U at points throughout the structure. What we're trying to do is that we want to look at a situation where we apply external load on. Let me just set an example. If we have a balloon and we press it, the force we apply on that particular balloon will cause the shape to deflate into a different shape depending on how we apply it. Now, that's the same thing that we're trying to apply here. Here we're trying to apply force on it. You can see how there's a change in length. If let's say there's a place that is marked, and then we apply that force, you can see the way the change let me say there will be a displacement. Now, what we always do in virtual work method is that we look at a situation where we apply a unit load on the so-called structure. We look at its deflection or its displacement, then we apply the real displacement on it and look at how it applies, then we multiply the two together. Now, for axially loaded member, this is the formula. You can read the notes on it. That is, a unit displacement is equal to summation of NNL over AE, where this N, that's the internal virtual force of the truss by the external virtual unit load, while this one is the external joint displacement, and N is the internal force, and L is the length of the member we're considering, and A is the area of the member, while AE is the modulus of elasticity. Now, if it is on temperature scenario, this is the formula. You can read up all these ones. Let's go to an example on it so that we don't waste much of our time. Now, let's say look at this member. The cross-sectional area of each member of this truss, as shown here, is that A is this, E is this. Now, assuming we have a force 4 kilonewton applied here, we want to determine the vertical displacement of joint C if a 4 kilonewton force is applied to the truss at C. And we want to look at the second scenario. If no load acts on the truss, what will be the vertical displacement of joint C if member AB were 5 mm too short? Now, we want to look at the virtual force. The part is that we apply the virtual force. Since the virtual displacement at point C is to be determined, a virtual force of 1 kilonewton, note 1 kilonewton, is applied at point C in the vertical direction. The units of this force are calculated and the virtual force in each member is determined by the method of joint. Though I don't know whether the method of joints have been taught already, but it's one of the analysis method for. We can use method of joint or method of sections or graphical method. So if we apply a unit force, then we will resolve what are the forces along the member based on this unit force. We record everything down. Then after doing that, we now treat the same real force. Now we have treated the virtual force. We now look at the real force. What are the let's say application of those? Let's say what are the member forces based on the real life situation? We put down what we have there. Now, the way the virtual work is very simple. Once we have determined this particular scenario, all we just need to do is just create a table where we write each member. This member AB, put it down. AB. This member AC, put it down. Member CB, put it down. Now, for the virtual work, what under member AB, what is its own? Member AB is 0.667. You put it down, 0.667. Member AC is minus 0.833. Minus 0.833. Member CB is minus 0.833 too. You put it down. Now, the same thing we did for the virtual, we are going to do it for the real load situation or real force situation. We put it down. We put this one down. We have 2, we have 2.5, we have minus 2.5. We put it down. Then we're now going to look at the length of each of those member. Length AB. What's the length of AB? AB is 8 meters. Then AB is 8 meters. AC, if you look at AC, you can always determine this. Let's say this is 3, this is 4, so you can know that this is 5 meters. So AC is 5 meters. Likewise, CB too. CB CB is also 5. This is for this 3. So this way is 5. Using Pythagoras theorem. That's easy to understand. So now after putting this down, all we just need to do is just put our summation of n times L. We multiply these 3 together, we have the value here. Multiply these 3 together, have the value here. Multiply these 3 together, have the value here. Just sum these 3 together, and that is so. That is your displacement. So you just put your A and E, substitute your A and E together. Since we are told that A is this, E is this, just put it under the something, and then we have our displacement as C, which is all. So the second question we were asked is that we were told that if no load acts on the truss, what will be the vertical displacement of joint C if member AB were 5 mm too short? Member AB were 5 mm too short. So we will not. This is how we're going to treat that one. The same thing we did on that one. We're going to do what's it called? Only member AB undergoes a change in length. So therefore, change in length equals to minus 0.005. So we just do this. 1 times this equals to this. So the n that we have before, we put it. The change in length is this, and then we multiply it together. Whatever we have, that's all. So the note only member AB is what we are asked to check the length. If it is for all of them, we have to apply it for all of them. But this time around, this is for member 1, member 2, member 3. But for this one, it's just only this one we are treating. So that's the only one we are taking based on that. And we have this. Then the negative sign indicates that joint C is displaced upward, opposite to 1 kilonewton vertical load. If the 4 kilonewton load and fabrication error are both accounted for, then the resultant displacement is this plus what we have earlier on, this. So by the time you add the two together, this is what you are going to have. So I think that is all on that. Let me close this section, then let me go for the third section, which is graphical method.